Welcome to the third in our series of videos on the Aurea evaluation software. In this lesson, we'll learn how to configure the analog front end of Microchip's MGC3130. This is a mandatory step which must be performed to adapt the system to a different electrode setup. For example, when testing new electrodes or integrating already parameterized electrodes into applications. To adjust the analog front end, 3 simple steps have to be performed. This includes signal matching, electrode mapping, and electrode selection. The best way is always to start with signal matching. In the plot below, the RX signal for each channel is shown during the first half period of the transmit signal. An optimal RX signal shows an overswing or underswing in the beginning and is settled at the sampling point. At the sampling point, the RX signal value must show a value close to 32,768 digits. This value can be tolerated up to plus or minus 20% thanks to MGC3130 AFE performance. In our case, we're using the MGC3130 Hillstar development kit, and as you can see in the diagram, the RX signals are already perfectly parameterized. But what happens if we change the electrode setup? Instead of using the standard 95 by 60 mm 4-layer PCB electrode that's provided with the kit, we're using different electrodes, in this case the GestIC demo board. The dimension of the electrodes is smaller, but it also features 4 layers with the center electrode in the middle. On this electrode, the channel order and the capacitance conditions are different. Once the board is connected, we can see that the red clipping indicator is on. We expect that the AFE signal matching parameters are totally out of range. So coming back to AFE settings, we press the Calibri Parameterization button. We recommend that you always choose the Load from File option and to start with an existing reference file provided for an electrode which is closest to the one in our application. For didactic purposes, we start with a new parameterization. We have to wait for a few seconds until the system is synchronized. As you can see, the RX signal levels are out of range, so the Calibri suite features might not work properly. Therefore, RX signal levels need to be adjusted. This can be done in the signal matching section. To configure the RX signal automatically, Aurea provides a function called auto-parameterization. By pressing the auto-parameterization button, you can see how the RX signals for all channels are adjusted automatically at the sampling point. The next step is electrode mapping. The MGC3130 features 5 receive channels. The feeding lines coming from the electrodes are routed to the pins RX0 to RX4. For proper functionality of the Calibri suite and its features, the orientation of the electrodes is important. Therefore, the electrodes are named after their cardinal directions: north, east, south, west, and center. The easiest way to do the electrode mapping is to look on the schematics and then to assign the electrodes to the respective pins in the table. But what can we do if we do not have the schematics to hand or want to verify the electrode mapping? The simplest way to determine the electrode mapping is to touch the electrodes with a finger. If we touch the electrode located in the north, the RX signal value of the center electrode rises. The center electrode is mapped to RX0. To rectify this, we assign the north electrode to RX0. If we now touch the north electrode, the RX signal of the north electrode rises. The same applies to the east electrode. Touching the east electrode leads to an increase of the west electrode. The west electrode is connected to RX1. All we have to do is to assign the east electrode to RX1. We finally verify the remaining electrodes, south, west and centre. As we can see, the respective signals go up, so we do not have to do anything here. By the way, both the signal matching and the electrode mapping parameters are real-time parameters. This means these parameters can be changed via firmware messages whilst the application is running. Finally, we can choose between a 4 and a 5 electrode setup up here in the electrode selection. If our application features a centre electrode, we select the option 5 electrodes. In case the application does not have any centre electrode, as in our case, we choose the 4 electrodes option. Changing these settings does influence most of the subsequent parameterization steps. If we actually click on the radio button, 4 electrodes, the software will show a pop-up and asks us to confirm the changes. Let us confirm with yes. We can now see that the centre electrode in the electrode mapping and signal matching box are greyed out, and that the RX signal of the centre electrode disappeared in the signal plot. Before we continue, it is recommended that you store the parameters to the flash of the MGC3130. This can be done by clicking the button Store in Flash. Today, we learned how easy it is to parameterize the analog front end of Microchip's MGC3130. Now we can continue with the next lesson, System Startup.